Okay, can you hear me? I can hear me, so hopefully you can too. Hopefully you're here to learn about some Kotlin, because that's what I'm here to talk about. My name is Justin Lee, as you can see, and I work for Red Hat. I don't currently get to write Kotlin in my day job, but I'm working on fixing that. Just by brief way of introduction of who I am and why my opinion might matter to you. I am a Java champion, which is, it's a whole thing, but I mention it mainly to say I've been doing Java since '96. I love Java, it's my day job, everything about Java I love. But Kotlin, however, is the first JVM language that's come along that's made me really excited to use something other than Java. I tried like crazy to like Scala, and I just couldn't get my brain around it. Groovy was not my thing either. And then I discovered Kotlin 5 or 6 years ago, and I thought, this is amazing. Now, all my stuff is, all my side stuff at least, is in Kotlin, and if I get a choice at work, it's in Kotlin, because I like it. So, just to get to know you guys, how many of you have heard of Kotlin before you got here? Most of you, good. It would be weird to come to a talk and you hadn't heard of it, like, I don't know what that is, but I'm gonna go. But people do it, and that's awesome. How many of you have used Kotlin? Fewer, but nice, well done. How many are really seriously considering it? Awesome, okay. So I've done a number of variations of this talk where sometimes I'll pick like a handful of things and do like medium dives into each topic, and those are instructive, but there's always more that I want to say. So the format for this particular talk is this. We're done with the slides. Go away. So this is the agenda for today. Make note of it. Don't get too attached to it, okay? Because this is just the list of things I'd like to get to. But we're going to start at the top, and we're going to work our way down. And we're just going to plow through as much as we can and dig into each one as much as I feel comfortable with and move on to the next, because I would like to get through all of it. But I like to do interactive talks. So if there are things that you're like, I'm not sure what that meant, or can you explain this more, raise your hand and shout out your question, and I'll try to answer it. And we'll get through as much as we can. I want it to be interactive, and I want it to be mostly valuable for you guys, because I'm already converted, so I don't need to see all this. But my hope is that when you're done, that you will agree with me that Kotlin is awesome and amazing, and you should all be using it, because it's great. So before I launch into the first little bit, I just want to say as kind of a meta comment, one of the things I like most about Kotlin is, I was talking to Roman, about data science, right? Python is like the big language in data science because it's an easy language for people to pick up, right? With Java, you have to, what's a class? Public static, what? What's void? Whatever. I'll just use Python, right? So there's all these weird things in Java you had to get used to, but Kotlin is a very low level, or a low barrier to entry language, along the lines of how Python is. And so for me, it's a great choice for teaching beginners programming, because you can just kind of jump right in and start doing things without having to understand everything all at once, whereas Java presents, there's certain things you just have to do before you understand it. So, but that's a little mini spiel. So, the first thing is Null Ability. Everyone has anyone heard about the Null Ability aspects of Kotlin's type system? A handful of you. Okay. So, what this means is, when you write Java code and you declare a string, that variable can be null, and you always have to check it, or you're going to get a null pointer exception sometime in your life, right? So Kotlin goes the other way, and it embeds the null ability as part of the type. So you can see here. Oh, also, I'm not going to explain the syntax unless someone asks, because most of it should be fairly obvious, but if it's not, we can talk about it. So here you can see we're declaring a name, and it's a var, so it's mutable, just like Java 10's var. There's also a val, if you're a Scala person, so you'll recognize those. But you'll see string with a question mark. Now, technically, that's called a nullable type, so it's a nullable string, but that's a bit of a mouthful. I like to refer to that as a string. You know, it's like sometimes you have a string, and sometimes you have a string. You just, and you have to check it, right? So in this case, what happens is, if I try to use, no, that won't work, because let's do this. Name.length. Everyone can see that red squiggle? I don't know how well it shows up on the big screen. Do I need to make the font bigger in the back? I tried to make it bigger, but we're all good? Okay, I was hoping it was big enough, but with this room, it's hard to tell. So the compiler knows that name is a string, and you didn't check for null, right? So chances are you're going to run into a null pointer exception at some point. So the compiler actually makes you check, right? So you can do that a number of ways. You can do it the traditional way in Java. Looks familiar, right? Check for null, and then you can use it. Now you notice the little squiggle went away, right? So there's a couple of things that in play here that makes Kotlin awesome apart from the null ability. This is what's called a smart cast, right? So the compiler just knows, I just checked for null, and I'm only going to get inside this block if name is not null, right? So there's no reason to ever consider that as a nullable value. It'll never be null inside that block. So the red squiggle goes away. So it smart cast it from a string to a string, right? Which is really nice. So if you're comfortable with your Java idioms, you can do that, and everything's fine. You can also do down here. So this is, I was getting mixed up, the Elvis operator. And what this says is, the dot says to dereference the variable. The question mark says only dereference the variable if it's not null, right? So it's a nice way you could actually do name length, and then you can assign it to a variable like so. And you can see the inferred type. Has everyone seen the inferred? If you haven't done Kotlin, you probably haven't seen the inferred type. The part in gray is actually just the IDE kind of overlays that into the text. It's not actually in the source code. It's just kind of an IDE hint of what the type is. But you can see it's an int, or an int. So that might be null, and it might be 12. Who knows? But if I do this, boom. Now I can guarantee that we're either going to get a length of the string or a 0, and now the type is int, right? So this is a little shortcut. You've seen the ternary operator in Java. Everyone's seen that, right? So this is the same sort of thing. Actually, I think this is probably called the Elvis operator because of the curl in the eyes. Doesn't matter. So this is a shortcut to saying evaluate the left side if it's not null, or give me the right side of it if it is. So either way, we're going to get a valid int value out of this expression, and then our type is int. So you can do this little question mark operator if you want. Another thing you can do for more complex situations is you can do, there's a extension function which we'll cover called let. So in this case, we're going to evaluate name only if it's not null, and this let is an extension function. And inside this lambda is what you're looking at behind it. There is a variable called it, which refers to name. So it is the non-nullable version of name. And then we can reference it inside and print the length as if it was not null, because it'll never be null inside that block. So it's a couple ways you can do the null ability checks. And you may think it's a little bit of a trivial feature to start off with about how awesome Kotlin is. But you cannot imagine. How many of you would like to chain your methods? Yeah, it's nice, right? What happens if there's a null in the middle of it, and you have to do a null check? What if there's like 4 null checks in the middle of that chain? It's a whole bunch of if not equal null, if not, it gets really gross really quickly. This, it just stops. You can chain your method. It won't work because string is too simple. But you could do stuff like this. So if you had foo, bar, baz, blah, blah, blah. It'll actually stop evaluating the second it finds a null reference in there, and then the rest of it just goes away. But you can still chain the entire thing as if you're not going to get a null, because sometimes you won't, and the whole expression will evaluate. But the second you hit a null anywhere in that chain, it'll stop at the question dot operator and just terminate. So it's a very nice way to handle multiple cases of nulls. So when you're wondering, why is he starting off with that? This is why. I mean, this alone, if they added this to Java, would be so much nicer. So many bugs are gone with that one. So, question or just shifting? Fair enough. Okay. Any questions before we move on? One more note, because we're not going to come back to smart casts. If you've ever done an instance of check in Java, you have to say if x is instance of string, and then inside you have to create another variable, string s equals foo, and then use s. It's annoying. So if we had, if we say any, that's the top type in Kotlin, other than, it's not object, it's any. But we can say if x is a string, then we can say, I'm going to get a red squiggle. Let's find out what the red squiggle is for. Oh, might not be initialized. So technically x is an any, and it's not really, the reference type is not a string, but we know that the underlying value is a string. So here we can do if x is string, and then inside the block, x gets smart cast from an any to a string. So everywhere inside that block, it's now a string. So smart casting works on null ability and types, because technically null ability is a type, but smart casting. All right, next. Yeah.
How could you not get the null pointer error warning for when you did x dot stuff? Go back to
Here?
yeah. I see that you initialized it, so it's fine. But
Do you see the type? Do you see the type I'm checking against?
yeah.
It says string and not string.
Yeah, sure.
So, because those are two separate types. And in fact, I don't think it doesn't even like to check if it's a string or string. But that's how you can tell. Because if it were, I think this will fail. Well, it'll compile. You'll actually never get into that block because it's always a string, I think. Here you can't do the is check with that guy. This says check for instance is always true. So it knows you're checking for something, it's always going to be that type. So, all right, so, yes?
Else operator. Do I have an else? If it's not, can I do stuff there?
With the, okay, so I'll need to correct. This is not the Elvis operator because I always get it confused. The Elvis operator is that guy, the question colon. And this is basically if else. So you can have foo and bar. And that's a shortcut for an if else. But the nice thing about Kotlin is that everything in Kotlin is an expression. So you could say, if foo blah else blarg. And that's valid, at least if you had an equal sign in there. So this is an expression. If is an expression. While is an expression. Try is an expression. I'm sorry. Kotlin uses when, not a while. So you ever do like a try block and you have to declare variables outside, declare your variable, try inside, catch your exception, then return that variable that may or may not have been initialized based on what happens in there. You can actually, in Kotlin, you can say return, try, blah, 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 blah. And in the try block, the last value is the return value for that block, and it gets returned back out of the try block, and then in this case, returned back out of your function. So you can just inline all that without all the local variables cluttering up your source code. And then, of course, if you get an exception, it just throws the exception out. So, all right. I added this next bullet point like 20 minutes ago, so I don't have source file set up.
What happens if you have a chain of method calls with question mark dot and it terminates? What's the value of that?
The return value of that will be null. If it terminates early, the return value of that expression will be null. And so you'll have to deal with that somehow, whether it's checking for null or whatever. But you could also do the question colon mark at the end of that. You could do return foo question mark dot, and then whatever your final expression is. And at the very end of it, you can say question colon and then some other expression, or you could actually throw an exception there. So you could say Baz. No matter how long I've done this, I always get that backwards. My fingers just won't do it. You could throw an exception, like so. And that's valid, because both sides of those are expressions. It gets a little tricky, a little digression. The throw exception returns nothing, which basically says it'll never ever return, so don't try to assign a type. So the return type for that is nothing, which is the base type of every single other type in the system. It's weird, but it's handy. So, okay. So anything else before we move on? Okay. Any Scala users? How many of you love operator overloading in Scala? I got 1.5 hands. And that's virtually everyone's reaction. So when I learned that they were adding operator overloading to Kotlin, I got a little nervous because I've seen some really gnarly Scala code using overloads, and they're not great. But Kotlin did kind of a halfway. With Scala, you can define any symbol to invoke any method you want, and you can make really expressive, but really kind of arcane code. So Kotlin went the other way. There are certain operators you can overload on, and they call fixed methods. So you can overload an operator on types, but you can't define new operators and new functions, essentially. So things like add, get, remove, things like that, they're all bound to what are more or less obvious. The plus sign is bound to add, so anyways, we'll see. So let's do a little brief digression here. Let's declare a map, and it's going to be a mutable map. Kotlin makes a distinction between mutable maps or mutable anything and immutable. So a list you can't add to, but a mutable list you can, right? That's one of the downsides of the Java API is sometimes you want an immutable list, but still listed as a list, and there's still an add method. And you call list.add, and then you get like the unsupported operation exception. Kotlin doesn't do that. Kotlin has explicitly mutable types. So that's one way you can declare a map, right? It's a function that returns a map, and this is of string to string. Another way you could do it is this. Well, I guess they're sort of the same. If you want to initialize your values, let's just do it here. You can say A to, typing in an angle on this thing is not easy. You say A to A, B to B. Now, that reads fairly straightforward. Everyone understands what's going on there, right? We're mapping this to that, right? So to is actually an operator. There's a couple of weird things going on in there. It's an infix function and an extension function that creates a pair, right? So you can declare infix, which puts all the operands on either side, and then mutable map of will take a list of pairs and convert it to a map for you. Now, if we want to add, we can do this. Map. Who wants to map C? So, doesn't look like the Java version. I remember Java you had like map.put blah, 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 and it gets long depending on what you're going on. So what Kotlin has done is it's defined an operator overload on this, if it'll click through for me. There we go. It's declared, you can see this keyword operator, says that it's an operator overload, and we're defining it on the set function on mutable map. So we're creating an extension function, which we'll look at on map, called set. And now everywhere where you see the bracket, at least in this particular case, we are going to call put instead. So you get a nice little shortcut into adding to a map. But you can also do this. And then that will do a get on your map, which makes it really nice. So you get the same syntax for lists. You can do bracketed index access into your list rather than do get 0 or get 14 or whatever. You can do the brackets. You can also assign that way into your list if your list is properly assigned. So you can define certain overloads in certain cases to make your code much more expressive without necessarily leading to the unmitigated hell that freely overloading operators can be if you're not given guidelines. So I point this out because we're going to build to something later. If you want to build DSL, these sorts of things can come in handy for changing the expressiveness, how you express your code. Yes?
I may be jumping ahead here, but is the appeal of Kotlin the syntactic sugar?
Is there a what?
Is the appeal of the language, is it the syntactic sugar? Is that it?
For me, it's a little mixture of both. There's a lot of syntactic sugar. When you compare Java 8 streams and Kotlin functional features, Kotlin is typically more succinct than the Java version. For reference, my brother, who is slower to coming to Kotlin love than I am, is converting a project from Java to Kotlin, and he took a class that was 239 lines, converted it to Kotlin, and now it's 19. And all he did was convert it to Kotlin. So should give you an idea of like just how expressive the language is, which is one of the things I like about it. So, no, the dot is not overloaded. The question was, could I do map dots like this? I don't think that's valid. No, it's not. That would be interesting. Make it very kind of JavaScript-y in that sense, which is probably why they didn't do it. Any JavaScript fans? Okay. We can still be friends. I have a lot of JavaScript friends. You can't not like JavaScript in these days, right? Okay. All right, so next, extension functions. We've looked at them briefly, but let's look at the syntax. I don't think we have extension functions. See, I already have classes built down for you. So here we have a string, and it's just my name, but we're going to call this name case function, and if you know anything about strings in Kotlin, which probably most of you don't because you just said you don't know Kotlin yet, there's no actual name case function in the standard library, right? But it's useful for me in certain cases. I want to be able to take this, I want to capitalize the J. How many of you have written that function where you capitalize the first letter in a word, but then keep everything else the same? It's so annoying, right? Because it's a static function, you have to pass in things, and there's return values, and it gets gross, right? So with an extension function, you can actually you can work toward a much more fluent API, so you don't have to break out and call a static function, because then you need like local variables to pass in things, then you're back into your fluent things. With extension functions, you can keep it fluent quite nicely. So this is what this looks like. So as you may have gathered, all Kotlin functions start with fun. And I don't know why func and def would have been like proper choices, but they went with fun. So there's our name case, that's our function name, but what you'll notice here is this string dot, if I don't mess up my code here. String dot. So what that is that's the receiver type for this function, which means that you can only call this method name case against a string. If I just try to call name case, I think it'll freak out on me. Yeah, it's like, what is that? I don't know what that is. But now we have a string, so we can call it. So then what happens is everything inside this function body is resolved as if it's part of the string class. You'll notice I refer to this inside the function. That this refers to this string that I called it against. So everything is contextualized to whatever you're calling it against, which will come in, again, super handy once we start talking DSLs. But even if you're not writing a DSL, if you're trying to write like a chain of functions and you're really working toward this fluent API and you're just like, oh wait, I need to massage this particular type that I don't own in a certain way, but now I have to write a separate utility function in blah, blah, blah. Now you can do an extension function, just attach it to that type and call it inline and just keep on rolling without having to worry about kind of all the ceremony of a static function. So in this case, you can see we are getting the first character. Strings can be dereferenced with indexed access like this, which is nice. Getting the first character, we're going to call uppercase, and then we're going to just give it the rest of the string, and now we've uppercased our string. So those are, in a nutshell, extension functions. And while we're here, another fun aspect of this is every class has a companion object. So Kotlin doesn't support static, but it does support companion objects. And so what an object is, for those coming from Scala, you'll recognize this. It is a type that is enforced to be singleton. You cannot create new instances of an object. You just get one for free, right? So each class has its own companion object, whether you define one or not. If you don't define any methods, there's nothing to do with it. But in this case, we're defining a foo. And in Java, that would be like a public static foo on the type extension functions. But in this case, it's just an object, and then you would call it, you can call it just foo because we're inside our type, because the resolution context is scoped to the class that we're on. Or you can explicitly call it, if you're external, you can explicitly say, here's the type, and here's the .foo. You'll notice that we did not say .companion or .object or anything weird. You just call it, and it looks like a static method call. Technically, it's not. Yes?
How is extension functions scoped?
Extension functions is just a class. So it's just a regular old class in a file. Everything's public by default in Kotlin. And that's a whole conversation we could have too.
Accessible to your whole project?
Yeah. Yeah, so in this case, it would be, in Java, this would be public class extension functions. And it's just a regular old class like everything else you've ever used.
Yes, exactly.
Oh, not the class, but the extension functions. It depends on where you declare them. I'm sorry. The question was, before I got totally confused, was when you declare an extension function, this is a poorly named class apparently, it's scoped to whatever lexical scope that you declare it in, to get slightly nerdy. In this case, we declared this particular extension function inside the class extension functions. So the only place you can use this without some stuff is inside extension functions. If I do private, then no one can use it except for extension functions. If I wanted to use it outside extension functions, you can do it. There are better ways to declare it than what I did here. But one of the nice things about Kotlin, which we haven't covered, is you can actually do this. I just declared a function outside of a class, which is a total no-no in Java. But now this function is declared inside. It gets weird. There is a class you'll find when you compile it called extension functions kt.class, which is a terrible name, I know. But and then at that point you can import extension functions kt.namecase and then use that extension function in whatever other type you want to. Does that make sense? Yes. The companion object. You can only have one companion object, but you can have multiple objects. And then you can say this object foo, object bar. You can have as many objects as you want. And you can, as you can see up here, we actually declare an object outside of the class as well. Does that make sense? They're an interesting wrinkle. They're not as exotic as it looks once you start using them. The simplest way to think of them, especially with the companion objects, is just think of them, these are static members on the class. It's not technically idiomatic to think of it that way, but as a Java developer, that's the essential equivalence of it.
Every object is basically a static.
Every object is singleton. Right. So I can't say new foo because it's an object. Well, I wouldn't say new in Kotlin, but that's beside the point. All right, everyone following along so far? All right, so that's extension functions. How much time do we have? 20 minutes. We're going to do this. All right, so go away. All right, so that was extension functions. Okay, so this next, I gave this talk at the Atlanta Java Users Group a while back, and I lost 90% of the audience, but we're going to try this because it leads to something interesting. So there's a thing called a Lambda with receiver, okay? And let me see if I have, I don't. Let me see if I can get it open. I knew there was one project I was forgetting to open. Okay. So this project, probably the font. Oh, the font worked out. So this project isn't entirely important what it is, but just for context, I used to work at MongoDB, and I would write unit tests, and I wanted to configure the database to do a certain thing, and I wanted to generate a configuration file before launching the server, and I wanted a nice way to configure that. So I wrote a DSL, as one does, right? So that's all this is. I'm happy to talk about it afterwards, but don't dwell too much on it because it's a little bit in the weeds. So what we're looking at here is a Kotlin DSL. Everything in here is statically typed. It looks sort of JSON-y, right, when you read it, except for colons instead of equals and this and that. But So you can write statically typed, compile time checked DSLs in Kotlin for whatever you want to do. The example on the JetBrains site is an HTML builder, which I could have shown, but it felt boring, and I wanted to build my own DSL. So let's look at how this works, okay? So this right here, this configuration is actually a function, and it looks like this. So it's a top-level function that's not in a class, and it takes an initial parameter called init, and then this. So this is how you declare that your function takes a lambda. So you have a function, and then you just pass in a lambda, and it does stuff, right? It can do whatever it wants because it's just a closure, right? But because this is a DSL, I want to be able to constrain what I can do inside that block and expose certain types of methods. So remember how I mentioned that extension function had a receiver type? So this is the receiver type for this lambda, okay? So this is known as a lambda with receiver. It's not terrible, but I mentioned that in Atlanta and people started, we don't know what that means. It took me a while to get my head around it. But essentially what it means is, just like with the extension function, everything inside the lambda that you pass in will be resolved against whatever the receiver type is, in this case configuration. And then just to round it out, I create a new configuration. You'll notice I don't call new. There's no new keyword in Kotlin because it's just line noise, right? Everyone knows you're creating a class. And then I can call, with this new instance I just created, I can now call init and execute whatever that lambda is against the instance I just created. If I were to take this off, now init is not resolvable because it's just a function. I can call it, and that works, but it doesn't really do me any good. It doesn't affect what I just did, right? So what this lets you do, though, is otherwise I'd have to pass in configuration, like so. It's not terrible, but it's not exactly like a clean DSL. So this is a lambda with receiver, and then in practice, then what that looks like is inside this is the closure that we're passing in. This system log is actually a different function that's defined on the configuration class. So now I can scope all the method resolutions to the configuration type, and then you can nest types. This actually, because it's a database configuration file, it nests down like 12 levels, and it's ugly. You can see all the different nested types there, but that's neither here nor there. So combining extension functions and lambdas with the receivers and this and that, we can create a really nice-ish DSL where if you've ever configured a Mongo database, my apologies, this is roughly what the configuration file would look like if you did the JSON version of the configuration file. So it let me, as a Mongo developer, configure an instance in something that looked like an actual JSON config file, but I could do it in Kotlin, and I can actually execute this code and have it do things, as opposed to just loading a JSON into memory and having to parse it. So that's DSL. So there's a whole talk on that one, but that is not this talk. And we have 10 minutes because we want more questions. All right, and we are done with you. Oh, did I just push the wrong button? No, I did not. Whew. Okay, so delegation. All right, who here likes to inherit classes? You're Java developers. Everyone extends classes, right? That's what you do as a Java developer. Whatever extends something. That's what we do in our day job. Now, if you're like me, you've heard the old adage, favor composition over inheritance. And you're like, that sounds like a great advice, but I'm a Java developer. It's just the language in the ecosystem isn't really set up to do that necessarily, unless you work really hard at it. But Kotlin does you one better. So let's look at the listogram. So this is an example I put together. Has anyone ever tried to implement list, Java util list? Yeah, there's like 30 methods on there, right? But you only want the one. And you're like, but I have to. Yeah. So you either have to implement them all or delegate by hand to some sort of nested instance, right? It's a lot of work in Java. Yes, your IDE can do it for you, but as your API evolves, you still have to go back and fix all the stuff, right? So this is an example. I subclassed some form of list, and I wanted to create a histogram to show the history of the size of the list. As I add and remove things over time, I wanted to see how it grew and shrank and everything, right? It's a silly example, but it makes a point. So, this. Kotlin supports inheritance by delegation, I believe is the title on the page. So, all right, so there's a lot going on in this. We're going to break it down. So, this little bit right here, to start off with, that's the primary constructor declaration. Now, what you're looking at is there are a few things. One, we're going to create a private field. That should be obvious. It's immutable. I can never reassign it, right? And it's a list. It's a mutable list. That part should be fairly self-explanatory, I hope. It's not terribly exotic. This is a default parameter for it. Everyone familiar with default parameters? Another thing Java should get. But what this means is, if I create a listogram and I don't pass in a list, the compiler will invoke this function for me and pass that in as its parameter. So I could just say listogram, and then I'm done, which is nice. But if I have an existing list, I can say listogram, my list, and that'll get passed in and used instead. So all of that is preamble to this. The colon, there's no extends versus implements distinction in Kotlin. It's all just colon, which is nice. And in this case, we're going to extend mutable list. It's going to be a list of string. Now here's the magic. By list. So this is the delegation bit. The delegation is usually keyed off of the word by. So what this means is, there are, as I said, 30-something methods on list that I don't want to implement, right? I want to implement some of them, but not all of them. So what this tells the compiler is, when there is a function on mutable list that is not implemented on this class, it's going to automatically delegate to the nested instance, in this case, the list variable that we declared as an instance field. Does that make sense? Which is really nice, because now all I have to do is I implement add, and implement remove, and you can see, I mean, it's not terribly exotic. I'm just changing sizes, right? And then I add one function. So in another version of this talk, I actually had the Java version of it, and it scrolls like 3 times, and then the challenge is find out what I added to list, you know. And it's hard. You literally have to look at each function because they're all there, right? But in this case, you can say, oh, all I did is I overrode add and remove, and that's it, and everything else does whatever it normally does. So add, remove, and then I added a histogram. Now, this is, if you've ever used Java 8 streams, anyone? Yeah, they're nice. This is slightly simpler in some ways. All this is doing is it's mapping things. It's grouping by times, and it's mapping the very last value. It's basically building the histogram, and I won't go into all of it because it's a bit ugly. But when I test it, I think I have this test. Yeah. So if I run the test, hopefully it'll compile. I just updated the Kotlin version, so. Oh, it's going to die because it doesn't matter. I don't want to take the time to run it. It'll print a histogram, and it's cute, and it's, you know, whatever. The point is, this is much more readable than the Java equivalent is, because we only have to really worry about 3 methods instead of all whatever's on them. So you can do this. This is inheritance by delegation, but Kotlin also supports multiple different kinds of delegation. Sometimes if you create a field and say it's going to be a name and it's going to be a string. Say you're mapping any Hibernate users, JPA? Yeah, so you have a field, you know there's going to be a value in it because you're going to slurp it out of the database eventually, right? But you don't necessarily want to initialize everything with an empty string or a null necessarily. It's just a little noisy, right, to do that if you had like 18 properties on your class. So there's a couple of ways you can get that with Kotlin. There's a late init keyword, which, it's going to make it not, it can't be non-nullable. So we know it's going to be a string eventually, but we don't want to initialize it just yet. So you can use late init, and there's also delegates not null string. And this introduces a little bit of magic. It creates it initializes it with a value, so it technically has a value, and then whenever you dereference this variable, it does some stuff behind the scenes to get your string in and out. But you only have to reference it as if it's a string. You don't have to worry about this delegates bit. I don't use this particular variant a lot because it seems like a little bit of overhead, but I prefer the late init version of it. But it depends on what you're doing. But you can also do, let's say instead of string, let's say this was, I don't know, some form of XML, right? And say it's a list of stock trades for the day, and you know it's going to be like 3 megabytes, 40 megabytes. Takes forever to parse. You don't necessarily want to parse that XML up front, right? So you could do this, and it's going to complain because there's not a body to it. But what this says is, this is going to have a string eventually, but don't evaluate it. The first time you try to dereference this XML field, it will then execute whatever that Lambda is, whether it's parsing XML or hitting the website to download whatever. It only does it the first time that you access that field, and then from then on, you have it in memory, but you're not paying that cost up front. The question is, with late init, how do you know you have a value or not? And the question is, the answer is better than it used to be. The answer used to be just, but now internally, I don't remember the syntax. I'd have to look it up because it's honestly not something I do very often, but there's an extension function. There is some syntax. It's a function of some sort. You can check inside the class. You can check to see if it's been initialized yet or not. It's a synthetic field on the type that you can access. So it's doable, but if you try to access this before it gets assigned, you'll get like a not initialized error or something like that. It's a weird exception, but when you see it, it's hard to mistake. You'll get it at runtime. Yeah, because at compile time, it won't necessarily know. Sometimes it can and sometimes it can't, but usually it's a runtime error. Okay, so that's delegation. Okay, inline classes, we have 10 minutes. I'm going to try and get through inline classes and sealed classes as quickly as I can, and the rest. Coroutines are awesome, but we'll save that for another talk, I guess. Okay, how many of you have written a method like this? It takes a string of doubles or ints or booleans or whatever, and you're not entirely sure, especially when there's multiples, you're not entirely sure what it's for, or you can't remember the order. Do I do this first or that first? And you get it wrong, right? Might just be me. It's fine. It happens a lot, right? Do you pass in the tuition rate, or the tuition, or the percentage rate? It's a slightly American-centric thing because tuition's probably not as big a deal for you guys to worry about because you're doing it right. But for us, it's a big deal. It's like, how much am I going to pay for this college, right? So in theory, you could do this. So you can see here I got it backwards. It's a 12% interest rate with 40,000. It's a 12% tuition, a 12 tuition rate with 40,000% interest rate, right? That gets really expensive really quick, right? Because we messed it up. So one option to do, there's this philosophy called tiny types, which I won't go into explain it because we're short on time. But the solution is to introduce classes, right? So now you have a type, right? You can't pass a rate in for tuition because it's a different type, and now your compiler can check to make sure that you have things in the right order, right? Everyone following me? Who can see the obvious problem with this? What is it?
Many. You have to create dummy classes just to keep one value.
Yes. That's not as big of a problem as you might think, but yes. The bigger one, for me at least, is now you have a whole bunch of these little tiny classes in memory, and your garbage collection is just going to, freak out at some point. So if we take a look at tuition, I want to open this up. How many of you can read bytecode? I can't either. So what this says here, it's the name of our function. This D takes a double, returns a double, okay? It's the primitive type for double, or close enough to it. Actually, it is a primitive type because it's Kotlin. So if we look at this other version, here's the overloaded, and you can see here it says process, it takes a tuition, and it takes a rate, right? Very obvious. But the problem is you still have these classes hanging around. So Kotlin has what they call, it's new in 1.3, which I'm pretty excited about, called Inline Classes. And it's a little bit of compiler magic. It can only have one field on the type, which is a sad restriction, but I understand why. But now, it's a class. You treat it like a class. You dereference variables like it's a class. And if we go back to here, we can pass values in. These are classes. If we were to do tuition dot, what is it, price. You see I can dereference it because it is a class, right? But, and there's my timer. Now if we look at the process method where we use these types, if you scroll back up, there it is. Notice the signature? Now it takes 2 doubles. So in the Java bytecode, you're actually just passing around these, they're primitives in Java in the bytecode for various reasons. But now, in the bytecode, it looks just like as if you just used double. But in your source code, you get the convenience of writing classes and have types and checks and everything. So you won't use inline classes everywhere, because there are certain limitations to them, of course. But in certain cases, these are awesome, because they make your code very clear about what's what and where goes where, especially if you have a long list of string parameters. I do a lot of object mapping, and so a lot of times you're passing around just like raw values, or you're not sure what's what. But these are great. And now we have 5-ish minutes, 3:47. I'm going to skip field classes because it's going to take a little bit longer to explain. Field classes are like enums, but you can subclass them, is the long and short of that one. And I'll show, if you want to come up after, find me in the hall and I'll show you. They're not as exotic as you might think, but they're useful if you like, you can subclass them and you can create 1 million instances of them, whereas enums, you get the one value, right, and you're done. So, but I wanted to leave time for actual questions because we have like 2 minutes left, 3 minutes left. 2 minutes, he says. Are there any other questions before yes?
I have another question.
Sure.
Why do you think Kotlin is better than Groovy?
The question is, why is Kotlin better than Groovy? So, and I know such questions are fraught with, like, you're dumb for thinking that, which is fine. It's certainly an opinion. Dynamically typed languages have never really worked for me. I've been doing C and then Java for too long, and then when a type can change its type and you're not sure what its type is in the first place, it makes it hard for me to reason about what my code is. But Kotlin's syntax is slim enough and succinct enough that you get a lot of the same benefits of Groovy, you know, less code, less boilerplate, but you still get strongly typed checks in your compiler and in your test and this and that. And it's faster than Groovy, to be honest, when you execute them. Shush. There's always that one guy. Anyone else? Yes?
Wouldn't name parameters be an easier solution than classes?
You could do that. The question is, wouldn't named parameters be a better solution? So you could do this, but it doesn't really help. With named parameters, you can actually declare which one is which. Do you see what I'm doing here? So I'm using the named parameter, and it's still backwards. I mean, it's a little bit more obvious because why would you have a rate of 40,000? That's insane. But it still compiles, right? Although it's all red and squiggly.
But it's the same as a ball, isn't it? You could also write petition in 12.
You could. But again, using the name parameters makes it a little bit more obvious, but using actual types makes it impossible. So you could pass a tuition of 12 and a rate of 40,000. You could do that. But when you're creating those types, it makes it more obvious. And then here, you could, with named parameters, you can explicitly say, this is the tuition, this is the rate, and then it would be obvious at least, but it still compiles, even though you've named them incorrectly. With types, you get a little bit typer checks. All right, that's it. I'm sorry. I hope this was helpful, and I'm happy to talk to anybody out in the hallway or whatever afterwards. Thanks for coming.